antibodies last a long time. Further, when you take the immunization, these antibodies last a long time. So when everybody is screaming about these antibody levels, there are multiple issues to keep in mind. First of all, antibodies will be lower in asymptomatic people, and they may drop quickly. But even if you're reinfected, if you had the natural illness, you are virtually guaranteed of less illness, right? The durability is now verified for at least 18 months. So you're going to say, well, wait. You know, we had this, and then they said within a year we got to do boosters and stuff. Look, we're going to go through that data, but I want you to keep in mind why that data needs to be interpreted very carefully. More so, not all antibodies fight the infection. This is going to be an important concept. You may not have heard this before, but it's true. It's always been true. It will always be true. Understand the following. When a virus gets a response from our immune systems, when you give vaccines, the body responds by producing antibodies. Well, not every antibody attacks the exact same way. These are a range of antibodies. And what happens is some of those antibodies will attack the virus in different locations, what they call the loci, what they call the parts of some of the proteins. In particular, everybody talks about the spike protein. Well, it turns out that some of those antibodies, when they go and attack a part of the spike protein, it actually causes the protein to alter in such a way that when that protein alters, it can be more likely to cause an infection. At 6 to 8 months, you will have about 25% of neutralizing antibodies. But the literature says you only need 3%. So everybody says, oh, the drop off. Yes, it drops off. But to prevent the things we care about, you only need about 3% of the antibodies left, right? 20% of antibodies still give you at least 50% protection, right? And this is just from getting some illness, right? We're not talking about the bad stuff. We're just talking about illness. These antibodies work, and they work at very low levels because you also have the cellular system, right? Now, the lab methods. You'll start hearing these things about efficacy. The problem is, when everybody says, oh, I want to check my antibody levels, I got news for you. There's no good data that when you look at these levels, that you can compare them between labs, that you can compare them over time, or that they will dictate that if you see a large titer, that it definitely means that you have efficacy, because how that's defined in the labs varies, right? They are predictive of immune protection. There's no question about it, right? There's no question that antibodies help. That's not the issue. The issue is how much do you need and how much vaccination do you need, right? And remember, at least 90% of people will develop good antibodies after a natural infection. It's the rare person that doesn't get a nice broader way from that natural infections, okay? Furthermore, if you have a natural infection, the memory B cells will produce antibodies against new variants. The systems that we have are geared that once they've seen a real infection, they adapt their antibodies into the future. So you have to understand why somebody getting the real infection can be highly beneficial. I'm not saying I want anybody to get sick. I'm not saying I want anybody to die. I am saying that you have to understand that in particular, when there's a mild variant, it is probably in your overall best health interests that if you got that mild variant infection, it would help protect you more. The FDA clearly states antibody tests do not indicate the level of immunity or protection. There's no clear titer level, and B cells dominate anyways. which is what I'm telling you. As a matter of fact, look at this. Look. This is a new test that's come out that looks to try to assay your T cells. And the idea there is to say, look, we can show you by looking at your cells that you're going to have a better immune response. And you're going to know what's possible with this testing, right? That gives you an idea of what has not been emphasized, as opposed to all the vaccinations, boosters, and antibodies, right? It is very important because it's very pervasive in helping protect us, okay? All right, rest stop, okay? So here we go. We've talked about the immunology. Now what I'm going to do is talk about some of the vaccines, okay? Stay with me. I know it gets a little complicated, trying to make it as clear as possible, right? So you may remember this. This is the different types of vaccines, right? And we've seen these in different types of diseases. Clear? And obviously the ones that we're talking most about, the new guy on the block, the mRNAs, very effective, very helpful, okay? And we look at the vaccines in development. These are some of the different ones you may have heard about. And obviously the big ones that we talk about, the Moderna product, right? The Pfizer product. Those are the two biggest ones, certainly in our country, and have grown to be very heavily used, okay? When you look at these vaccines, they have now become approved as opposed to EUA, and they talk about the different types of reactions that you can get. So this has been well looked at, okay? So what are their efficacy and safety? First, I want you to remember, very, very important, a vaccine will prevent disease, not infection, or asymptomatic viral shedding. So that's an important concept to always keep in mind. You want to know what is these vaccines doing, and what they're doing is they're preventing the bad stuff, right? They're not going to stop infection. They're not going to stop spread. Folks, this is going to be with us forever. Just like the flu has been with us forever. This is, although people don't use the term well, this is endemic, which means it's around. It's always going to be around in some form or another because it's always been around. It was just milder forms before this change, right? So if you have these around, how do you know, are they going to cause trouble? What's the risk, right? So there are 4 systems in the United States that we use for looking at trouble. Be Safe, VAERS, CISA, and VSD, okay? And let's take a look at each of those. Just so you've heard it once, you know what they do, right? So VSafe, this is with the CDC, and they have a mechanism where people can be volunteers on vaccines to check in with the CDC on a little texting, and the CDC collects data about the vaccines, the boosters, and it takes people that are willing to kind of spend the time doing that. If you ever want to do that, they'd be happy to have you do that, right? Next, the next one is the VAERS, okay? So this is co-managed by the 2 of them, right? And what the VAERS does is it has a mechanism where it takes everybody that sends in any report anywhere and puts it all under one roof and just starts collating. So you could imagine that the strengths versus limitations, the strengths, it's national data. It rapidly detects signals because you're getting so much poured in there. So what could be poured in there, though, could be wrong. People could say, oh, I had a reaction. That's got to be from the vaccine, but it may not be. So the good news is it lists a ton of stuff. The bad news is it takes time to go through and look at that data and decide, is it real or is it not, right? CISA, the third one. So there are some clinical research centers with vaccine experts at different facilities, and they are geared towards receiving reports from doctors, from health systems, from the government to analyze, and they look at different reports of difficulties. And they can be helpful because they really have a lot of consultants working together to try to round that up. Last one, number 4, then we're done with the reporting systems. VSD, the Vaccine Safety Data Link. So this is, again, health systems. So there's 9 integrated healthcare systems looking at 12 million people, and trying to decide what's going on with them. And it's very good. Got the computers and the links and all that stuff, right? So what happens when you do that? Well, let's take a look. Klein and JAMA looked at 10 million on this and found no data for any increased risk of any serious effective vaccine. Zhu looked at 11 million people and said, help with the deaths, not just COVID. You say, hey, that all sounds great. Yet we know that there are side effects. And these are some of the more worrisome ones. Guillain-Barré, clotting, a severe skin reaction, anaphylaxis, myocarditis, which is inflammation of the heart. And these things happen. So when people start saying to you, well, we looked at all the safety signals, it looks fine. Look, you got to be very careful, right? One of the trade-offs of what was otherwise an incredible achievement with Operation Warp Speed and with the mRNAs is you got vaccines to the population in an incredible time with incredible efficacy. No question about it. It's fantastic, right? But there's going to be times where some of these little things take a while to surface, right? Let's look at this. In the Janssen product, right, they had 54 cases of clotting, right? So they said that females were more common, right? The women tend to be younger. And they had a more worrisome one, which was central venous sinus thrombosis, which is a clot up in the head, okay? Next, who was at risk for those troubles? Well, these are the risk factors. So now we know that if somebody's obese, has hypertension, diabetes, is using estrogen therapy, has had clots in the past, okay, then they may be